Hello everyone, welcome to Gate Academy Global. Welcome to Gate Academy. So previously we discussed that how can we justify that which of the rivet in the connection is the critical rivet. Now what is the use of that idea? Before discussing this example, I will be telling you the proper way to justify a particular question. Okay, so the question may come in which the diameter of rivet is to be calculated, and to calculate the diameter we will be using the strength criteria given in the question. And previously I have mentioned, okay, if you have seen the lecture properly, I have mentioned that the shear failure will be there. The only shear failure will take place in case of eccentrically loaded rivet. We will not be considering the crushing and the tearing. Okay. So the shear stress will be the primary stress which will be considered while designing, as the permissible shear stress, like in this question you can see permissible shear stress will be given in the problem. Okay. So if the dimensions of the rivet, that is the diameter, is to be calculated, then the permissible shear stress will be given in the question. So there will be two types of question. In one of the question you will have to calculate the primary and secondary shear force in critical rivet. This kind of questions will be there. Okay. Second kind of question, the permissible shear stress tau permissible will be given, and you have to calculate the diameter of the rivet. This will be the question. Okay. Or there will be some different combination of the question which will be discussed in the workbook and numerical answer type questions. Okay. Now these are the fundamental types of question. Now in this situation, that is whenever you want to decide the dimension, that is called designing. So for the selection of proper diameter to carry a certain load, we will be designing the rivet. This will be the problem of a particular design problem will be there. Okay, this will be a particular design problem if we have to select the diameter of the rivet. So for any designing, the fundamental idea is to equate the induced stresses and the permissible stresses, because for safety the induced shear stress or the induced stresses should be less than the permissible stress, and in this case the only stress that we have is the shear stress, hence the induced stresses should be less than the permissible stress. And for limiting condition, we will be calculating the least diameter, this limiting case, that is tau max, okay, or tau induced, the maximum shear stress or maximum induced shear stress. This is the maximum induced shear stress will be equal to tau permissible. Okay, and tau permissible can be written as SYS divided by factor of safety. Now if you are using maximum shear stress theory, then SYS will be equal to 0.5 times of SYT. If you are using maximum distortion energy theory, MDED, then SYS will be equal to 0.577 times of SYT. Okay, this will be the value of shear strength of the material. So this will be the shear strength of the material, and if the factor of safety is given in the problem, just divide these values from the factor of safety, and then you will be having the permissible shear stress. Okay, and in order to design, you will be equating the permissible stresses to the maximum induced shear stresses. Now using this, you will be calculating the least diameter. Whenever we use the limiting condition, basically we are calculating the least diameter which should be there in order to avoid failure. So if diameter is coming out to be like, if D is the diameter, the value of diameter is D after calculation, then this diameter will be the minimum diameter which should be there in order to avoid the failure. Okay. So if the diameter is coming out to be, let us say 20 mm is the diameter of the rivet after calculation, then the minimum diameter should be 20 mm. You can take a diameter higher than that, but in gate examination we will be putting the value which will be obtained by solving this equation. Okay. Now the maximum shear stress can be calculated using the maximum resultant force, maximum resultant shear force. So in previous video I have told you that if there are 4 rivets, so there will be 4 resultants, R1, R2, R3 and R4, and the rivet in which the resultant force is highest is known as the most critical rivet. So this limiting case will be applied to most critical rivet. It will be applied to most critical rivet. Okay. So for designing we will be using the greatest value among these. Okay. Let us say if R3 is highest, let us say if R3 is highest, so we will be using R3 for designing. Okay. Now let me ask you a simple question, that in which rivet the resultant force will be highest. Okay. So as we have seen in the previous video, we had 4 rivets like this. This was the primary shear force acting in upward direction. Okay. This is P1 dash, this is P2 dash, this is P3 dash, this is P4 dash, and this is the line joining the centroid and the center of the rivet. This is R1, this is R2, this is R3, this is R4. Okay. And this is the secondary shear force. Okay. This is the secondary shear force, P1 double dash. Okay. This is P2 double dash, this is P3 double dash, and this is P4 double dash. Okay. Now the resultant will be highest in which of the rivet? This is the question. Okay. And I have told you the formula of resultant will be root over P1 dash P dash square plus P double dash square plus 2 P1 dash P double dash cos theta. This will be the formula for the resultant. This will be the formula for the resultant. Okay. Now we know that cos theta is equal to 0. Okay, 0 if theta is equal to 90 degree. Okay. Cos theta is equal to 1 if theta is equal to 0 degree. Okay. So we can say that if theta is tending towards 0, cos theta will be tending toward 1, and from this equation, if cos theta is tending toward 1, or if cos theta is equal to 1, then what will be the resultant force? This will be root over P1 dash square plus P dash square plus P double dash square plus 2 P1 P2 P dash P double dash. Okay. So this will lead to a solution like this. This will be P dash plus P double dash whole square. Okay. So on solving, this will be P dash plus P double dash. Okay. So if theta is tending towards 0, or you can say for a small value of theta, for a small values of theta, resultant will be high. Resultant will be high. Why am I telling you this? If you know this concept, this is very easy. This can be easily understood by observation. Okay. If you are a good observer, you can observe these things. Okay. So being a smart student, you must observe, and if you don't know then how to observe, then I am telling you, right? I am telling you that how can you observe these things. So if the theta is low, then definitely the resultant will be high, and if the resultant will be high, then that particular rivet will be the most critical rivet. So I am not saying that this will be the value of resultant. No, this will not be the resultant. But I have told you that if the angle between them is 0 degree, that is cos theta tending towards 1. So in that case, this will be the resultant force. Okay. There may be a situation where resultant is exactly equal to this. But the fundamental thought which you must have is, if theta is small, then resultant will be high. Okay. So in this case, as you can see here the angle is theta 1, here the angle is theta 2, here the angle is theta 3, here the angle is theta 4. In case of symmetrically arranged rivets, few of the angles will be same, few of the angles will be different. Okay. Now if let us say from here you can see that the magnitude of theta 2 and theta 3 will be almost equal, it will be equal, yes, and as this is symmetrically arranged, if this is symmetrically arranged, then this will happen. Okay. This is for only symmetrical arrangement, and theta 4 will be equal to theta 1, okay, for symmetrical arrangement. Okay, for symmetrical this will happen. Now, so if the theta is small, then the resultant will be high, and if theta is 0, so the resultant will be sum of the primary force and the secondary shear force in that particular rivet. So this is for theta equal to 0 degree. Okay. So based on this idea, you can judge that which of the rivet will be the most critical rivet. Okay, just draw the diagram. If theta is coming out to be very small or 0, then that particular rivet will be the most critical rivet, and it will be observed later on. I will be telling you more concepts and more shortcuts so that you will be able to judge the rivets. Okay, now this is the fundamental understanding. So based on this, if the critical rivet is known, then in that case you will be able to consider which of the following resultant is the highest. Okay, so this resultant will be highest. We can directly examine that which of the theta is lowest. Then based on that particular observation, directly calculate the resultant for that particular rivet only. Don't waste your time on calculating the various resultants in that different rivets. Okay, as in gate examination you will be having very limited time. So if you are able to observe that which of the following rivet is the most critical rivet just by looking into the question based on these concepts, then your time will be saved. Okay, so if R3 is highest, so tau max will be equal to R3 divided by area under shear, that is pi by 4 d square, where d is the diameter of the rivet. Okay, d is the diameter of rivet. Okay, and this should be equal to tau permissible for designing. Okay, we will equate this value with tau permissible and we will solve and we will get the value of diameter. Okay, so this is the fundamental idea of designing. Okay, now let us see this example. So here, for the arrangement shown in figure, the permissible shear stress is 75 megapascal. This is tau permissible. This is tau permissible. Find the diameter of the rivet. Okay, now this is this. Here we have arrangement of rivets, and the rivets are arranged across the circumference of a circle which is having a diameter of 100 mm. The eccentricity E is equal to 200 mm. The external load is 50 kilonewtons. Okay, so as this is a standard geometrical shape, okay, and you can clearly see that it is arranged symmetrically. Okay, if you make a reference like this, just by making the reference axis, you can see that the rivets are arranged symmetrically with respect to the reference. Hence the radius will be the centroid. This will be the centroid only. Okay, this will be the centroid. Okay, so centroid will be having, that is G will be having a coordinate of 50, 50. This is x bar, this is y bar, and both are in mm. This is the centroid. Okay, so let me make a separate diagram for this. This is the rivet. Okay, so this will be, so the centroid is been located. Okay, as I have told you previously that there will be diagrams, there will be standard shapes, so that you can observe the centroid or the location of centroid, you say, directly by looking into the question. And in some cases there will be a need of solving properly by using the formula of x bar and y bar, which I have told you in the previous lecture. Okay, so the location of centroid is known. Okay, location of centroid is known. So x bar is equal to 50 mm, y bar is also equal to 50 mm. Okay, so this the step number 1 is completed. Okay, now the radial distance, this, let us say this is rivet number 1, this is rivet number 1. Okay, this is rivet number 2, this is 3, this is 4. So this will be R1, this will be R2, this will be R3, and this will be R4. Okay, now according to this, okay, this will be the force is acting downward, so hence the reaction force will be acting upward. So this is the direction of direct shear force. Okay, this is the direction of direct shear force. Okay, this is R1, this is P1 dash, this is P2 dash, this is P3 dash, this is P4 dash. Okay, and the external load is causing clockwise sense of rotation, okay, about the centroid. So the resisting moment will cause anti-clockwise sense of rotation. So this will be the direction of resisting moment. Okay, this should be the direction of resisting moment. So this will be the direction of secondary shear forces. So this will be P1 double dash, this will be P2 double dash, this will be P3 double dash, okay, and this will be P4 double dash. Now from this question you will get some important concepts, so watch the lecture carefully. I will be telling you about the effect of angles between the primary and secondary shear forces. Okay, so it is very easy to calculate the primary shear force. Okay, so primary shear force can be the primary shear force okay, all the forces will be same in magnitude. Okay, so P1 dash will be equal to P2 dash, it will be equal to P3 dash, and it will be equal to P4 dash, and the P4 dash, and this will be P divided by N. The number of rivets is 4. There are 4 rivets, and P is 50 kilonewton divided by 4. So this will be 12.5 kilonewton. 12.5 kilonewton, or you can write 12,500 Newton. This will be the primary shear force. Okay, primary shear force. Now, then we will be calculating the radial distances R1, R2, R3, and this is arranged along the circumference of a circle. So R1 will be equal to R2, it will be equal to R3, and this will be equal to R4. Okay, in different situation, the R1, R2, and R3 can be calculated using simple trigonometric equations. Basically, you will be using the Pythagoras theorem. Okay, and that will be very easy. So this is equal to the radius, that is 50 mm. Okay, this is 100 mm in diameter, so the radius will be 50 mm. Okay, now as the radial distances are known, then we can calculate the secondary shear forces. Okay, secondary shear forces. Okay, so now as the radial distances are same, and we know that the secondary shear force P double dash is directly proportional to radius, and each and every rivet in the arrangement is placed at equal radial distance with respect to the centroid. Hence, we can say that P1 double dash will be equal to P2 double dash, it will be equal to P3 double dash, and it will be equal to P4 double dash. So all the secondary shear forces are equal in magnitude because they are at equal distance with respect to the centroid. There may be a problem where the radial distances are different. Okay, like this, if there will be 6 rivets in the connection like this, okay, and this, then definitely this will be the centroid. I am just giving you an example. Okay, so this is the centroid of the arrangement G. Now this is basically arranged along the perimeter of a rectangle. All the rivets are being arranged in the perimeter of the rectangle. Then these are the extreme edges. So these 4 rivets will be having same radial distance, and these 2 rivets will be having same radial distance. Okay, so the secondary shear force in this rivet and this rivet will be the same, and the secondary shear force in these 4 will be the same because these distances are same. Okay, so this will be the idea. So just remember this relationship. Okay, so then you will be able to relate that which of the forces, secondary shear forces, will be equal in magnitude and which will be different. Okay, so now the value of C, as you know, C is equal to P into E divided by R1 square plus R2 square plus R3 square plus R4 square. Okay, and P double dash is equal to C into R. So once you have calculated C, then you will be able to calculate any of the shear forces, secondary shear forces. Okay, so just calculate the value of C. So this is P is 50 kilonewton, so 50 into 10 raised to power 3, okay, into E, eccentricity 200 mm. So as I am putting the force in Newton and the dimensions in mm, so the stress will come definitely in Newton per mm square, that is nothing but the megapascal. Okay, so stress will come in megapascal. Clear? So this will be divided by R1 square. So R1 is 50, everything is 50, every radius is 50, so this will be 4 times of 50 square. Okay, this will be 4 times of 50 square. So let me calculate the value of C. So this is 50 into 10 raised to power 3 multiplied by 200 divided by 4 times of 50 square. Okay, so this is 1000. C is coming out to be 1000. Okay, C is coming out to be 1000. Okay. If I ask you what will be, is the C dimensionless or it is having a dimension, then what should be the answer? Here you can see in this equation, this is the load, that is shear force basically. So P double dash, the dimension of P double dash will be Newton, okay, and this will be R will be in mm or meter, that is definitely in the dimension of length, okay. So let us say SI unit is there, so this will be meter. So the unit of C is coming out to be Newton per meter, okay. So C is not dimensionless, this will be having a unit of Newton per meter, okay, and here the lengths are used in mm, so this will be Newton mm, okay, Newton per mm. So the value of C is 1000. Now we can calculate P1, which is equal to P2 double dash, which is equal to P3 double dash, which is equal to P4 double dash as C into R1, okay. So this will be 1000 into R, that is 50. So this is coming out to be 50 into 10 raised to power 3, okay. So this much secondary shear force will be there, okay. So don't get surprised because it is having exactly same magnitude as that of the external force. So many times the student will feel that my answer is wrong and he will check it again, okay. So it is not like that, the secondary shear force may be higher than the external force, okay. So this is the fact. This is because the secondary shear force is not induced due to the external load, it is induced to encounter the moment produced by the external load, okay. And the simple idea is that if you want to rotate something at a longer distance, then you will be needing less force, okay, and if you want to rotate something at the smaller distance, then you will be needing a larger value of force. So it is very simple that if you have a hinge over here and it is a seesaw where in which the hinge is placed at this distance, then here if you are putting 100 Newton of the load, then here you cannot put 100 Newton, you must put a load larger than 100 Newton. So that is the very same reason. So this is the same condition as that we have in Rivet. So in Rivet, the reaction moments are induced within the arrangement of the rivets, and here we have very small distance and the load is acting at a very large distance. So definitely there will be a chance that the secondary shear force may have a magnitude higher than the external forces, okay. If it is coming lesser than that, that is also okay, but if it is coming higher than the external load, then it is not a big deal, it is common, it can take place, okay, it can occur. Now this is the magnitude of the secondary shear force. So we can just solve the problem. Now the next thing is to calculate the value of thetas, okay. Here both the forces, that is primary and secondary shear forces, are at angle of 90 degree. Here both are acting in same direction. Now don't get confused, okay. If two forces are acting in same direction, then the angle will be 0 degree. So here theta 2, here theta 1 is 90, theta 2 is 0 degree, okay. Here again theta 3 is again 90 degree. Here theta is not 0 because they are acting opposite to each other, okay. So if two forces are acting opposite to each other, then what we can do, just draw a diagram like this. If you have any doubt, if this is a force and this is a force opposing it, like this, so just draw a point, okay. Let us say this is force F1, this is force F2, so this will be F1 acting through the same point and this will be F2 acting through the same point. Now you can see that the angle is 180 degree. So here, as the forces are opposite to each other, so just remember, if you had no idea about this, okay, if you are confused with the angles, then just remember that if two forces are acting opposite to each other and they are acting along a same line, that is they are collinear but opposite to each other, then the angle is not 0 degree, the angle will be 180 degree, okay. So here theta 4 will be equal to 180 degree. So this will be the value of angles. Now based on the angles, as I have told you that for theta equal to 90 degree, cos theta will be equal to 0, okay. So if cos theta is equal to 0, if theta is 90 degree, cos theta equal to 0, so resultant will be root over p dash square plus p double dash square, okay. This will be the resultant. Okay, and if theta is equal to 0 degree, then we will be having the maximum value of resultant. So if I ask you which of the following rivet is the most critical rivet, so without any doubts your answer will be rivet number 2. This rivet will be the most critical rivet. So theta 2 is equal to 0 degree. Okay, and also if there is possibility that two rivets will be having same value of theta, here we have only one rivet which has the minimum value. It may be possible that the arrangement of rivets is such that two rivets are having same value of theta, or there may be more than two rivets which is having same value of theta. All of these conditions are possible. Okay, but just have a proper calculation of theta so that your answer will be correct. Okay, so here we have calculated everything in a proper manner. So theta is 0 degree only for one rivet, that is rivet number 2. So theta 2 is 0 degree. So this is, or it is the most critical rivet. Most critical rivet. It is the most critical rivet. Okay, so R2 will be maximum resultant shear force. Okay, hence tau max will be equal to R2 divided by pi by 4 d square. Okay, and this should be less than or equal to tau permissible. So minimum diameter required to avoid failure is obtained by this equation, that is R2 divided by pi by 4 into d square is equal to tau permissible. Okay, so R2 will be P1 dash plus P2 dash plus P2 double dash. Okay, as the angle is 0 degree. Okay, so for 0 degree, that on adding up the primary and secondary shear forces you will be directly getting the resultant force, or if you have a value which is non-zero, then just put the value of primary and secondary shear forces in this equation, and hence you will be getting the value of resultant. Okay, so here we can directly use the addition of two shear forces. Okay, so divided by pi by 4 d square is equal to tau permissible, that is 75. Now 75 is in megapascal, so 75 megapascal is same as Newton per mm square. Okay, so this is Newton per mm square. So let us solve. So P2 dash is 12,500. Okay, and P2 double dash is 50,000 divided by pi by 4 d square is equal to 75. Okay, so on solving we will be getting the value of least diameter which is required in order to avoid the failure. Okay, so make the calculation. You must use a virtual calculator, as I have told you that virtual calculator will be there in your gate examination. So either practice manual calculations, avoid the use of calculators. Okay, or if you are practicing with calculator, then use the virtual calculator, as I don't have to give gate examination. Okay, so I can use scientific calculator, but you must use the virtual calculator. And also I have told you that you must use the virtual calculator with the mouse, just buy an OTG key. Okay, you use an OTG cable, connect a mouse with your mobile phone and operate the calculator with the mouse only, because in gate examination you won't have any touchpad. Okay, you have to operate the calc by using the mouse. So if you are practicing the virtual calculator with help of a mouse, then your command over the virtual calculator will be very good. Okay, so on solving, the diameter of the rivet D is coming out to be 32.57 mm. Okay, 32.57 mm, or you can write it almost equal to 33 mm. Now if this were a conventional question and if you are using a data book, then based on the manufacturer's catalog we will be selecting the next extended value. It may be possible that we have a diameter of 30, we don't have a diameter of 33 in the manufacturer catalog. That means according to the manufacturer's catalog we cannot produce a rivet a rivet of diameter 33 mm. Okay, hence we will be using the next greater value. Why we will be using the next greater value? Because this is the least diameter required in order to avoid failure. If the diameter is less than 32.57 or 33 mm, then definitely shear failure will take place. Okay. Now, let me tell you an important concept, that in which row the critical rivet will be placed. Okay. What will be the location of the critical rivet? So, the concept is valid for symmetrical arrangement. Okay. First of all, it is valid for symmetrical arrangement. So, note down, it is very important, note that if rivets are symmetrically arranged, if the rivets are symmetrically arranged, okay, then the most critical rivet is the one, okay, which is closest to the line of action of load, okay. So, let us say we have a riveted connection like this. Here we have an eccentric load, here we have rivets like this. Okay. Now, here these two rivets, if it is 1, 2, 3, 4, if this is rivet number 2 and 3, then both the rivet 2 and 3 are closest to the line of action of the load. Okay. Hence, rivet number 2 and rivet number 3 may be the most critical rivet. Okay. And also, it is also true. Now, if we have 6 rivets like this, so this is also the symmetrical arrangement. Okay. Then also what will happen? We will be able to calculate which of the rivet is most critical. But the concept which I have delivered will be more helpful if the radial distances R1, R2, R3, R4, if all are equal. That means the symmetrical arrangement means with respect to the center, or with respect to centroid. Now, why I am saying that with respect to centroid? Because if there will be 6 rivets, okay, and if you draw a reference axis like this, then also it can be treated as a symmetrical, it may be taken as a symmetrical rivet. But here this is symmetrical about the x-axis and the y-axis. This is symmetrical about the x-axis and the y-axis. But if you take a cylindrical coordinate, okay, then it is not symmetrical about the centroid of the arrangement. Okay, because these rivets are placed at a certain distance, these 4 are having same distance with respect to the G, and these 2 are having same distance. All the 6 rivets are not at equal distance. So, symmetrically arranged means with respect to centroid, that is symmetrical arranged with respect to centroid. Okay. Then the most critical rivet is the one which is closest to the line of action of the load. Okay. And here, as you can see, that all the rivets are at same distance with respect to the centroid. Hence, these 2 rivets, that is rivet number 2 and rivet number 3, will be definitely the most critical rivet. Both will be having same magnitude of resultant force, and this can be observed. Just take an example, just take any load, okay, any dimension, and then solve the problem by yourself, and then you will be getting the results. Whatever I have told you is correct. Just remember that in case of symmetrically arrangement with respect to centroid, definitely the closest rivets, the rivets closest to the line of action of load will be the most critical rivet. So, here also, if you know the concept already, now we have discussed everything in detail. If you can't remember the concept, just go for the conventional approach, okay. But if you can remember the concept, then definitely according to our concept, this rivet, that is rivet number 2, according to our nomenclature, this will be rivet number 2, and this is closest to the line of action of the load. So, definitely if you know the concept, and this will be the question in your GATE examination, you will be choosing this as your most critical rivet. okay. And then this is the line joining the center of the rivet and the centroid. This will be the direction of secondary shear force, okay, which will be always perpendicular to this line joining the center and the centroid, and this will also be the direction of the primary shear force, and they are acting at an angle of 0 degree, and none of the rivets will be having the same configuration. So definitely this will be the most critical rivet. Then you will be calculating the diameter of the rivet at the very first approach, and this will be very easy for you. So this was the important concept regarding the eccentric loading. Okay, now let us see few more example and few more important concepts regarding the eccentric loading condition. So now we will see another example. So here we have 4 rivets in the question which are arranged in the vertical line, okay, and they are equidistant from each other. Okay, the distance between each rivet is 40 mm, as you can see from the figure. Okay, so here we don't have to calculate the centroid. Okay, so as they are symmetrically arranged, you can see they are equidistant with each other. So the total the centroid will be lying in the vertical plane only, okay, and as they are equidistant and total distance 40 plus 40, that is 80 plus 40, that is 120, and if you take a reference, that is this is x direction and this is the y direction, so the x coordinate will be 0, okay, and the y coordinate of the centroid will be 120 divided by 2, that is 60 mm. So here we have the centroid, so this is the centroid, okay, and the distance is given as in the diagram. The centroid was previously mentioned, but I have also told you that how can we calculate the centroid, okay, and the eccentricity is 100 mm, the load acting on the riveted connection is 100 kilonewton, and it is an eccentric load, okay. So we have to calculate the worst rivet and we have to calculate the resultant force in each of the rivet. So as the centroid is calculated, so we will be starting with the primary shear force. So the primary shear force, okay. Now primary shear force will be equal to P by N, and this will be equal to P1 dash, P2 dash, P3 dash, P4 dash, okay. So this is equal to 100 kilonewton divided by 4, that is 25 kilonewton, okay. So this will be equal to P1 dash, P2 dash, P3 dash and P4 dash, okay. So this is the primary shear force acting on the rivet. Now we can calculate the secondary shear force, okay. Now secondary shear force, to calculate the secondary shear force we need to calculate the radial distance first, okay. In previous lecture we have discussed what should be the proper procedure in order to calculate the diameter or anything. So there is a proper procedure of, so secondly we will be calculating the radial distance, okay, as the secondary shear force is directly proportional to the radial distance. So let us see the radial distances. So this distance is 60 mm, okay, this distance is 100 mm. So this distance will be equal to 60 minus 40, so this is 20 mm, this is also 20 mm, okay, and this distance will be 60 mm, okay, 60 mm, this will also be 60 mm. So basically R1 will be equal to 60 mm, also R4 will be equal to 60 mm. So you can write R4 equal to R1 equal to 60 mm, and R2 and R3 will be 20 mm, okay, and as P double dash is directly proportional to R, hence the secondary shear force in the first rivet and the fourth rivet will be same. The secondary shear force in the second rivet and the third rivet will be the same, because the radial distances of these rivets are same with respect to the centroid of the connection, correct. Now as the radius are known, now we can calculate the secondary shear force. So first of all we will be calculating the constant C. So this will be P into E divided by R1 square plus R2 square plus R3 square plus R4 square. So P is 100 kilonewton, or you can write 100 into 10 to the power 3 Newton, okay. So this will be 100 into 10 to the power 3 into E, that is 100 mm, okay, eccentricity is 100 mm, divided by R1, that is 60 square, plus R2, that is 20 square, plus 20 square plus 60 square, okay. So let us calculate the value of constant. This will be Newton per mm, Okay, so this will be 100 into 10 raised to power 3, okay, into 100 divided by 60 square plus 20 square plus 20 square plus 60 square. Okay, so C is coming out to be 1250 Newton per mm. Okay, 1250 Newton per mm. Now P1 double dash will be equal to C into R1. Okay, P2 double dash will be equal to C into R2, C into R2. P3 double dash will be C into R3. P4 double dash will be equal to C into R4. These two will be the same and these two will be the same. Okay, as per our previous discussion, these two will be the same. Okay, now so P1 double dash equal to P4 double dash equal to C, that is 1250 into R. R is 60 mm. Okay, so 1250 into 60. Okay, so this is coming out to be 75,000 Newton. Okay, this is coming out 75,000 Newton. P2 double dash and P3 double dash will be the same. Okay, so this will be 1250, that is C into R. Okay, so 1250 into, so this is 25,000 Newton. Okay, so let us draw the diagram which will represent the primary and secondary shear force. So this is the riveted connection. Okay, okay, so this is the direction of the primary shear force. This is P1 dash, this is P2 dash, this is P2 dash, this is P3 dash, this is P4 dash. Okay, now as you can see that the external force will be creating a clockwise sense of rotation about the centroid. So the rivets will be producing an anti-clockwise sense of rotation about the centroid, hence will be requiring the direction of force like this. Okay, so this is the centroid G. So here we will be having the secondary shear forces. Okay, so this will be producing an anti-clockwise sense of rotation. Okay, so this will be P1 double dash, this will be P2 double dash. Okay, this will be P3 double dash and this will be P4 double dash. Okay, and this is the line joining the centroid and the centers. This is the line joining the centroid and center. So here for each and every rivet you can see theta 1 equal to theta 2 and equal to theta 3 equal to theta 4 equal to 90 degree. Each and every rivets, in each and every rivet the theta is 90 degree. Now how can you judge that which of the following rivet is the most critical rivet, as in this case all the values of thetas are same, and previously we have discussed that the rivet in which the value of theta is minimum will be the most critical rivet. Okay, now as you can see, okay, I am telling you the concept. As you can see that the primary shear forces are same in each rivet, but the secondary shear forces are highest in the rivet number 1 and rivet number 4, and rivet number 1 and rivet number 4 are the outermost rivet with respect to the centroid. Okay, now I can make an conclusion after solution. Okay, first of all let us solve. So the resultant in this equation, in this solution will be, first for resultant R1, resultant R2, resultant R3, resultant R4. Okay, as the value of theta is 90 degree, so this will be root over P1 dash square plus P2 dash square, then 2 P1 dash P2 dash cos theta will become 0 because theta is 90 degree, cos 90 is 0. Okay, again this will be P2 dash square plus P2 double dash square, this will be root over P3 dash square plus P3 double dash square, this will be P4 dash square plus P4 double dash square. Okay, now let us put all the values. Okay, now P1 double dash and P4 double dash are same, and P1, P2, P3, P4 dash are same. So here these two will be same. Okay, R1 and R4 will be same, and R2 and R3 will be the same. Clear? all of these are same, and these are same, these two are same, and these two are same. So definitely this will follow, correct? This will follow. So just calculate R1. So R1 equal to R4 will be equal to root over P1 square. What is P1? P1 is 25 kilonewton, that is 25,000 square, okay, plus P1 double dash, that is 75,000 square, okay. Now, so this is 25,000 square plus 75,000 square. So here R1 is coming out to be 79056.9415 Newton, okay, and R2 and R3 will be root over 25,000 square plus 25,000 square, okay. So this is coming out to be 35355.34 Newton, okay. Now it is very clear from the solution that R1 and R4 is higher than R2 and R3. So now we can make a conclusion that if, okay, this make an important note that if rivets, okay, rivets are arranged vertically, okay, and load is acting parallel to arrangement of rivets, okay, same as that of this case. Here also we have vertical arrangement of the rivets, okay, and the line joining the rivets and the line of action of the rivets are parallel to each other. So basically the row of rivet is parallel to the line of action of the load, okay. So here you can also write row of rivet is parallel to line of action of load, okay, is parallel to the line of action of load. So in that situation, the outermost rivet, okay, with respect to centroid will be the most critical rivet, okay. So which is the outermost rivet? Rivet number 4 and rivet number 1 and rivet number 4 are the outermost rivet. So rivet number 1 and 4 are the most critical rivet as well, okay. So this is the critical rivet. Now what we have to calculate? The worst rivet and the resultant force. So worst rivet is okay, worst rivet is rivet 1 and 4. Now the resultant force on the rivets 1 and 4 is 79056.94. So this is your answer. This is the resultant in the critical rivet, okay, resultant in critical or inverse rivet, okay, inverse rivet. So this will be your answer, okay. Now let us see another example. Now here we have another example. So here you can see that the rivets are arranged in a horizontal line, okay. So there are only one row of rivet, and here we are applying the load, okay. Now in this particular problem you can see that the load acting on the rivet is passing through the centroid, okay. This will definitely be the centroid. So this is a simple problem, okay, like lap joints. This is the simple problem, because in lap joints and butt joints we have also discussed that the line of action of the load must pass through the centroid. So if the line of action of the load is passing through the centroid, here line of action of load is passing through centroid of joint, then there will be no rotational effect, there will be no moment of the external force about the centroid. So as there is no moment of the force about the centroid, then definitely the secondary shear force will be 0. Okay, then secondary shear force will be 0. Okay, then secondary shear force will be 0, and the shear force, or you can say the resultant shear force, will be equal to primary shear force. Okay, so R will be equal to P by N, where N is the number of rivets. Okay, rivets. Also, it may be possible there that the load is acting at a certain distance with respect to the centroid. Okay, so there may be another case like that, like this. If you have a bracket like this, okay, and you are applying loads P. Now this is the centroid of the joint. Let us say this is 40 mm. This is again 40 mm. Okay. Now, as you can see, this is the line of action of the load, and this is the centroid of the joint. So there is some eccentricity E. Okay, there is some eccentricity E. Now, here again you will be having a primary shear force and secondary shear force. So as you are getting moment of the external force across the centroidal axis of the rivet, then definitely you will be having a secondary shear force. So here we will have secondary shear force. Here we will have secondary shear force. Okay, so this will be the primary shear forces. Let us say this is 1, 2, 3. So this is P1 dash, this is P2 dash, this is P3 dash. Okay, and this is the sense of rotation. Okay, this is sense of rotation. Now this will be the direction of the primary and secondary shear forces. This will be the secondary shear force P3 dash. This is P3 double dash. This will be P1 double dash. Now P2 double dash will be 0. P2 double dash is 0. So what does it mean? That if a rivet is placed at, that if the rivet is placed at centroid, then the secondary shear force will be 0 for that particular rivet, even if there is secondary shear force in the joint. Okay, so in joints at different rivet there will be secondary shear force, but for the rivet which is at centroid, for the rivet at centroid, secondary shear force will be 0. Okay, because the radial distance on which the secondary force depends, P double dash, is directly proportional to R, and R will be 0 for such rivet. Okay, for such rivet which is placed at the centroid. So definitely the secondary shear force will be 0. Okay. Now here, if I ask you which will be the most critical rivet, so this is the centroid, and these two are placed at equal distance. Okay, so R1 and R2 are same. So again you will see that C will be equal to P into R, to R1 square plus this will be R3. Okay, R3 square. Okay, and R1 is equal to R2. Okay, hence again the rivet which is farthest from the centroid will be having the greatest value of secondary shear force. Okay, will be having the greatest value. This will be having the greatest value of these shear forces, secondary shear forces. Now, as the radial distances are same, then these two shear forces, secondary shear forces will be same, P1 double dash and will be equal to P3 double dash. Now, if I ask you which will be having the greatest shear stress, that is the greatest value of resultant shear stress. So, as here P3 dash and P3 double dash are acting in same direction, hence this will be the most critical rivet. This is the most critical rivet. Okay, this is the most critical rivet. Now, as you can see that this rivet, that is rivet number 3 and 1, is equidistant from the centroid. But why is this having the greatest resultant stress? Because this is having the greatest distance with respect to the line of action of the load P. Okay, so we can make a conclusion, so make an important note that if line of action of rivets, line of action of load is perpendicular to row of rivet, in an eccentrically loaded rivet joint, okay, then the rivet which is with a distance which is farthest, okay, which is placed at highest distance from line of action of load will be the most critical rivet or worst rivet, you can say. Okay, so in such case where the line of action of load and the row of the rivets are perpendicular to each other, so in this case the rivet which is placed at highest distance from the line of action of load will be the most critical rivet. Okay, so definitely the rivet number 3 will be the most critical rivet. So if the value of eccentricity is known, let us say eccentricity is 20 mm, then you can easily solve the problem. So data will be, just take the same data, load will be equal to 15 kilonewton, permissible shear stress is 70 megapascal, okay, and find out the diameter of the rivet in this condition. You can find out the diameter in this condition. Okay, what we have to do, just calculate the value of primary shear forces. Okay, so primary shear forces, that will be required only for the critical rivet, and the critical rivet will be the rivet number 3. So we will be calculating only for rivet number 3. So P3 dash will be equal to P divided by the number of rivet, that is 3, that is 15,000 divided by 3. So this will be 5,000 Newton. Okay, and also we can calculate the secondary shear force. So P3 double dash will be equal to C into R3. Okay, so this will be P into E divided by R1 square plus R3 square into R3. Okay, so P, that is 15,000 into E is 20 mm divided by R1 and R2. R1 and R3 both are 40 mm, so 40 square plus 40 square into 40. Okay, so here we have 15,000 into 20 divided by 40 square plus 40 square, okay, into 40. So 3750 Newton, 3750 Newton will be the secondary shear force. Okay, this will be the value of secondary shear force. Okay, now as you can see, the angle between these two forces, primary and secondary shear forces, is theta equal to 0 degree. So they will get added. You can directly add these forces. Okay, so resultant force will be P3 dash plus P3 double dash, because theta is equal to 0 degree. If theta is not 0 degree, then you will be using the conventional formula. Okay, so this will be 5,000 plus 37 150. Okay, so 5000 plus 3750, this will be R equal to 8750 Newton. Okay, this is the resultant force on most critical rivet. Okay, resultant force on most critical rivet. Okay, so tau max will be equal to 8750 divided by pi by 4 d square, where d is the diameter, and this should be less than or equal to the permissible shear stress, that is 70 megapascal or 70 Newton per mm square. So minimum diameter required to avoid failure will be obtained by equating 8750 divided by pi by 4 d square to 70 Newton per mm square. Okay, so 8750 okay divided by pi by 4 where pi by 4 into d square is equal to 70. Okay, so the diameter is coming out to be 12.61 mm, or you can write it as 13 mm. So round up the value, so the diameter of the rivet should be 13 mm, or rivet hole should be 13 mm. Okay, now this was about this problem. Now in this problem, that were our initial problem. So in this problem, the only force acting on the rivet is the primary shear force. Okay, so the shear force, that is shear force or resultant shear force, was equal to primary shear force. So every rivet in this situation, every rivet is a critical rivet. Okay, because the resultant force acting on each and every rivet is same. Okay, so here, like that is the situation where the load or line of action of load passes through, if line of action of load passes through centroid, then each rivet is a critical rivet, okay, and the proof is each and every rivet is having the same resultant force. That's why each rivet is known as a critical rivet. So you can choose any rivet and design for that. Okay, so here the resultant force will be P by N, that is 15,000 Newton divided by 3, that is 5,000 Newton. Okay, so the tau max will be equal to 5,000 divided by pi by 4 d square, and this should be less than or equal to the permissible shear stress. Okay, and the minimum value of diameter, okay, required to avoid failure will be obtained when tau max will be equal to 70, that is limiting case. Okay, so 5,000 by pi by 4 d square is equal to 70. Okay, so solve this equation. So 5,000 divided by pi by 4 into d square and equate it with 70. So this will be from here. So diameter of the rivet to avoid failure should be 9.536, or you can write d should be almost equal to 10 mm. Okay, for safety this should be equal to 10 mm. So this was about the riveted connection. Okay, now we will see some workbook questions which were asked in previous year in GATE and in different examination, and they will help you to build a better concept. Okay, thank you very much.